we're going to be talking about our cubic and quartic functions. So we slightly addressed cubic on that parent functions set of notes that we did. We didn't talk a lot about our quartics. So that's what we're going to do today. We're going to take a look at their graphs, their domain and range, and some of their key characteristics. So first, it says that we are going to sketch a graph and find the roots of the following functions. So there was a bullet point on the board saying we all would need a graphing calculator. So if you don't have a graphing calculator, grab one for yourself. And we are going to start with putting these functions in our graphing calculator and taking a look. So you're going to go to y equals, and in y1, I want you to type in this equation. So you're going to put in y1 negative x cubed plus 4x squared plus x minus 7. Okay? Once you have that function typed in, I just want you to hit graph so we can see an overall view of what this function looks like. Okay, so it looks like on the far left it's going up, right? And then it drops down, goes back up, and then goes down continuously, right? Okay, so it wants us to draw a sketch of approximately what we think this looks like. So I'm going to draw a picture showing the end behavior that we see here. So we know this end is going up. We're saying it comes down, and then it starts to go back up somewhere around here, and then back down somewhere like this, right? Okay. In addition to drawing a sketch of the graph, it says to find the following. So we're looking for the roots of this function. So we're going to find the following roots. Remember, roots is another word for zeros or another word for x-intercepts, right? Those all mean the same thing. So really, I'm looking for where is this point, and this point. I need to find their exact location. So we're going to need to use our calculator to do that, because if you're looking at your graph, it doesn't look like these maybe intersect exactly on a line, right? They're somewhere in between. Okay, so there's a couple ways we can do this. In my opinion, the easiest way is to find where it intersects the x-axis, okay? The x-axis is the line 0, right? So we're going to go back to y equals, and in y2, I just want you to put 0. So it'll graph that line 0. So now you should have a red line on your x-axis when you hit graph. Everybody see that? Put in 0 in y2. Okay? All right, so now I'm going to find where they actually intersect. So in order to do that, okay, so you put this in y1, and then in y2, you put 0, okay? Now you're going to press second, trace, and our goal is to figure out where those two things intersect, right? So second trace, number 5 is the one that says intersect. So choose number 5. And then you're just going to move that floating dot closest to whichever x-intercept you want to find first. So maybe I want to find this one right here. Okay, the one I just put the red dot on. I'm going to move that flashing dot using the left arrow pretty close to that spot. And then you just press enter 3 times. 1, 2, 3. And it'll give you an approximation as to where that point is. Were you guys able to find that intersection? Okay, so approximately where does it say that is? Yeah. For the sake of notes today, let's go 3 decimal places, so that way we're being pretty exact. So it'd be negative 1.253 if we go 3 decimals, comma 0. Okay? All right, let's do it again. This time, let's find this point. This one I just put the blue dot on, okay? So all I have to do is press second trace 5, and this time move that flashing dot really close to that point. When it's close, you just press enter 3 times. Okay, approximately where does it say this one is? 1.4, what'd you say? 80. So this is at 1.480. Good. Awesome. Okay, so he already found the last intersection point, this one that I put a green dot on. And he said this one is at 3.773. All right? Okay, I want us to do the exact same thing on number 2. So you guys do the same thing for number 2, and then we'll share our answers. I'll walk around. If you need help with your calculator, let me know, so that way I can help you figure out how to find it. Oh, okay, just a little bit different, I guess. Let me know if you need my help. What about you take pictures, okay? You good on typing it all in? Okay. And then you good on typing it? You good, Zach? Yes, ma'am. Okay. And then what do you think? Good. If you want to note it, put it up there on the board. If you want to note it down on your paper, second trace 5. That way you don't forget when it's time for the assignment.
It is.
So that's second trace 5. Whichever one you find first, you're going to go over to it. So yeah, you want to find that one first? Yep. We'll just press enter 3 times. Perfect.
Second one is negative 0.650.
Okay, so can somebody tell me approximately what this graph looked like? What'd your sketch look like? Okay, all right. So started somewhere over here, went down something like this, and then started to come back up. And then here, and then maybe a little bit deeper on this side possibly. And then something like that maybe? Approximately like this? Okay. All right. So how many zeros does this one have? 4. All right, so we got 1 here, 1 here, 1 here, and 1 here. Okay, so where would we say that this 0 furthest to the left is located? Good. Perfect. Okay. And what about that second one? Good. Perfect. Okay, what about that third point? What's its location? Okay. All right, and then that fourth and final point? Nice. Okay, perfect. So now we can give a sketch as well as find the zeros. Even if they're not nice, neat numbers, we know how to locate them in our calculator. Perfect. Okay. All right, so now that we can find its zeros, it goes on to say they want us to draw the parent functions x cubed and x to the fourth on the graphs below. All right, so we have a general idea of what these look like, okay? But when it comes to transforming them, we do need a few concrete points, right? So what's a point that you know for a fact is on the graph x cubed? 0, 0. Okay, perfect. So let's put that on here. What else we got? Any other points? 1, 1. And then -1, -1. Perfect. Okay, so let me remind you guys that these are just points where you had some x value, and when you plug it into x cubed, the y is what you get out of it, right? So like, for example, that 0.11, when I plug in 1 cubed gives me 1. So that's the point, right, 1, up 1. If I plug in -1 cubed, -1 cubed is -1, so it's the point -1, -1, right? If you wanted to fit any more points on there, you could do like 2 cubed. What is 2 cubed? 8. So that means the point 2, 8 is also on this graph, right? Okay, I could also plug in a -2. What's -2 cubed? -8. So the point -2, -8 also on this graph. And nothing else is really going to fit on this picture, so that'd be the most. But let's make a little list here just so that we have those in our back pocket. So we've got -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Okay. So when I go and connect these points, oops, make that small. Okay. Gonna look something like this. Right? Okay. So, looking at this picture, what would you guys tell me the domain is? All real numbers, because it will continue up and down infinitely, as well as left and right. That means my range is also going to be all real numbers. So it goes up and down and left and right continuously. Perfect. Okay. All right, for x to the fourth, we may or may not know a bunch of values on this graph, right? But we could do what we just said we were doing and plug in some numbers, right? Okay, so if I plug in 0, 0 to the fourth power is what? Okay, so it must have the point 0, 0. Okay. What if I plug in 1? What's 1 to the fourth power? 1. Okay, what if I plug in -1? What's -1 to the fourth power? 1, right? -1 times -1 times -1 times -1. Okay, so -1, +1 is on there. I can try plugging in 2. 2 to the third was 8. So 2 to the fourth would be 8 times 2, which is 16. So not going to fit, right? Same if you were to plug in -2. Wouldn't quite fit. Okay, so I'm going to make a list of a few points that we now know for a fact are on here. And if we'll remember them, then we won't really have to worry about trying to think of any points. All right. Just so happens the 216 isn't going to fit on there. So we just have these 3 points. But if 216 is a point and it won't even fit on the grid, that means it does look like a parabola, but this thing's really skinny, right? Because its next point is only one line over from the current point, but it's up 16, right? Okay, so it looks something like this. Okay, so what would we say the domain of this is? All real, so it will go left and right forever. What about my range? 0 to infinity. Also could be written as y is greater than or equal to 0, right? Okay, all right. So keeping that in mind, flip it over on the back. Now we're going to graph some transformations. So we're going to want to keep these sets of points in our back pocket so we have some points to actually transform, right? Okay, so number 5 says we're starting with the equation y equals x cubed. So this is going to be a cubic function. It says it's going to stretch by a factor of 2 in the y direction. So that means up and down, right? Where do you put a number that shows a stretch vertically in an equation? In front. Okay, so we're going to have y equals, we got that stretch of 2. It also says it translates 3 units to the right. Where do you find left and right in an equation? In a parentheses. Okay, so I'm going to have to make a parenthesis after that 2. And it said to the right, so I'm going to put -3, right? Because it's always opposite of what we would normally think. All right, now, this was a cubic function, so what exponent do I need to put outside of that parenthesis? Okay, and make sure you do put it outside the parenthesis, not inside, okay? All right. Well, quick reminder, we just wrote down a few points on the front page that we said are points from the parent function of our cubic, right? The points you guys wrote down with me were -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8, right? Okay, so we just need to figure out what do those points become when we apply these 2 transformations. So I'm going to write my new points over here on this side of the graph. Okay, so it says that this 2 is a stretch vertically or a stretch to the y. So that means I need to do what to all of my y values? Multiply them by 2. Okay, all right, so let's go and do that. I'm going to multiply all of these numbers by 2. All right, so -8 is going to become -16. -1 becomes -2. 0 stays 0. 1 becomes, and 8 becomes 16. All right, okay. Then it says we also shifted 3 units to the right. So if I'm at -2, and I move 3 spots to the right, where do I end up? 1. So what do you do to get from -2 to 1? Add 3. Okay, so we're going to go and add 3 to all of our x values, right? Okay, so like you guys just said, -2 plus 3 would be 1. What's -1 plus 3? 2. And what's 0 plus 3? And 1 plus 3? And 2 plus 3? 5. Nice. Okay, so we're going to now plot these points, and it should be our transformed graph, right? So we've got a point at +1, -16. Not going to quite fit on our graph, right? So next point, +2, -2. That'll fit. Next point is at +3, 0. Then we got one at 4, 2. And that last one, 5, 16, that's not going to fit either, right? Okay, so we'll just connect these to give us our sketch. So it looks something like this, right? Okay, so let's think about it. The original graph we know would have started at 0, 0, but this one was shifted 3 units to the right, so it looks like all that makes sense, right? All the points shifted 3 to the right. And then instead of just going up 1, we went up 2 because there was a stretch by 2. So that looks good, right? We did go up 2. Perfect. Okay. So now that we have our new graph, what would you guys say our domain is? Still all reals. And your range? Still all reals. Good. Okay. All right. Let's do another transformation, but this one says it's for the function x to the 4th, so our quartic. Okay, it says this one is reflected over the x-axis. What do I put in an equation to show it's reflected over the x-axis? A negative. So I'm going to put a negative out here in front of my equation. And then it says it's translated 2 units down. Where do I put that? Yeah. So since we aren't shifting left and right in this one, you don't have to put any parentheses. You could if you wanted, but not necessary. So at the very end, he said, is where we're going to put that down to. Okay, perfect. Okay, and again, on the front, we made a list of a few points that we know are on our quartic parent function. So I'm going to copy those down over here for us so we have those points to use. We had negative 2, 16, negative 2, 16, negative 1, 1, 0, 0, 1, 1, and 2, 16, right? Okay. All right, so first thing they said that was happening is we were reflecting over the x-axis. So if I was on a coordinate grid, I had some point up here, and I reflect it over the x-axis, that brings it down here, right? What changes about the coordinate point? Yeah, the y becomes negative. So that's what we're going to do, right? We're going to change all of our y's signs. Okay, so we'll have, for our new points, all of these are going to become negative. So I'm going to just do that over here first. So I'm just going to put a negative in front of all of these values. 0 won't change, right? But all the others, I'm just going to stick a negative in front of for now. Okay. In addition to that, they said we also are going to shift down, right? If I'm shifting down, is that changing y's or x's? Y's. Okay. So not only was I supposed to change them all to negatives, now I need to move them all down 2 places. So mathematically, what am I doing if I'm moving down 2? Subtracting 2. So I'm going to subtract 2 from all of these y's. So it sounds like we actually aren't going to have to do anything to our x values, right? So my x values are going to stay negative 2, negative 1, 0, 1, and 2. But that 16, we changed it to a negative 16, and then we subtract 2. That's going to give us what? Negative 18. Good. All right, and then that 1 became negative, so now I got negative 1 minus 2. That's going to be negative 3. Okay, and then 0 minus 2, right, and negative 1 minus 2, right, and then negative 16 minus 2 is that negative 18, right? Okay, so now let's go and plot these points. The 2 and negative 2 aren't going to fit, right, because negative 18 won't fit. But we can plot all the others. So we got negative 1, negative 3. We got 0, negative 2. And we got positive 1, negative 3. So it looks something like this, right? So it still has that parabola-like shape, but it now, instead of pointing up like the parent function, has been flipped over. And instead of starting at, oh, I didn't plot that point at the right spot, did I? Instead of starting at 0, it's now been shifted down 2, right? Okay, so we got something that looks like this. So what would you guys say the domain of our transformed function is? All real numbers. What about the range? Yeah, it's going down, right? So off to negative infinity. So negative infinity to negative 2, or y is less than or equal to negative 2. Okay, awesome. Okay, last thing we're going to look at. It says to write the equations for the polynomials that we see here. So remember, we're only talking about cubics and quartics today, so this has got to be one of the two. That first picture, is that a cubic or a quartic function? Cubic, okay. So we know this is a cubic function. All right, and we know that our cubic parent function normally has a point at 0, 0, right? It looks like that new point, that new origin point is now right here, right? So how would you guys say that we shifted to get from here to here? What happened? Okay. So left 3, he said, and also up 2. Okay. And then normally we would have a point over 1 and up 1, which it looks like we still have, right? So no kind of stretch. It's not reflected. So these are the only two changes we need to write in the equation. All right. So my equation would be y equals, how would I write it? Nice. Making sure we put that cube outside the parenthesis. Awesome. Okay. All right, what would you guys say the second picture is? Cubic or quartic? Quartic, okay. So that tells us it's going to have that exponent of 4. Normally, we have a point at 0, 0, right? But now it looks like that point is over here. So what did you guys say happened? Okay. And what else? And left 4. Okay, awesome. All right, and then again, normally we go over 1 and up 1. It does appear there's still a point there, right? So no stretch happening. So that's all we have to say. So what would my equation be for this one?
X plus 4, quartic, minus 3.
Okay, so the x plus 4 in our parenthesis with the exponent of 4. Nice. And then the minus 3 on the end. Perfect. Okay,